Today, we're going to add some interest to our equations by putting the variable on both sides. And what I mean is that if there's an x term, it's on the left, and there's also an x term on the right. And we're going to learn today how to solve equations that have variables on each side. Now, before we head into that idea, let's just get some vocabulary kind of back in the forefront. So I need the word that represents the number in front of a variable term. So like this is a term, that 4, this is a term, that -3, the -1/2, 5. What are those numbers called that are in front of a variable term? Begins with a C. Did you remember that it's called a coefficient? Now, terms that have exactly the same variable, see the x and the x, see the y and the y, with the same exponent, see the x squared and the x squared. Now, over here, you might say, well, what are these? What is the exponent for the y? Remember, it's the invisible 1. Same thing with the x's. When you have the exact same variable with the exact same exponents, those are called like terms. Now, let me give you some examples that are not like terms. So notice that the variable isn't the same. And down here, notice that the variable is the same, but one has the invisible 1 for the exponent and one has a 2. So these are examples of not like terms, and these are examples of groups of like terms. What is a number called that doesn't have a variable? A term without a variable also begins with the letter C. Another word for not changing, not varying, and they would be called constants. Okay, so now what we're going to do is we're going to go forward and just going to take a second from 6th and 7th grade just to remember how to combine like terms. Now remember that a like term has to have the exact same variable. So the -3a and the 4b are not going to be like terms, okay? And the same exponent, which is fine here. So the first thing that I'm going to ask you to do is to change all your subtractions to plus and negative. So this minus is going to become plus and negative. That will stay a plus. This minus is going to become plus and negative, and I believe I showed you under here. So each minus became plus and negative, and each plus obviously stayed the same. So we're doing same change basically. Now, once you do that, it makes it easy to combine those like terms. So we have a positive 2a and a -3a, which would combine 2 plus -3, add the coefficients, and you would see a -1a. Now, are there any other like terms? Oh, here's a -1a. So the -1a plus the -1a would give us -2a. And what you can kind of do as you go through here is you can kind of cancel out the ones that you've done. So we did him and we did her and we did that one. And now we're going to go on to our B's. So this is a positive 4b, and that would not be a like term because there's no b, that's a constant. And a 4b and a -2b, 4 and -2 combine to make a positive 2, and don't forget the b. So now we could come over again and say, okay, we're done with that one, and we're done with that one. So now we just have to look, oh, there's just constants, and there's a -4 and a positive 1, and those combine to make a -3, so it would be plus a -3, and we could switch it back to the -3 to be a little bit tighter and a little bit cleaner. If you have -2a plus 2b plus a -3b, that's the same answer. And now what we did was we basically cleaned up the house. We put all the a's together, we put all the b's together, and all the constants together. What I'd like you to do right now is pause the video, and you're going to change all the minuses to plus and negative. And I forgot to mention up here, if you don't see a coefficient, it's the invisible 1. So in front of this -a, notice we slipped in the -1. So the first thing you need to do is write on your paper this, change all the subtractions to plus and negative, and insert the invisible 1s. Okay, let's see how you did. So just check yours. This minus became plus and negative. I slipped the invisible 1 in front of the R. This minus became plus and negative, and I slipped the invisible 1 in front of the P. And now I'm going to go across looking for P's. So -2P, jump over him, plus 10 P's. -2 plus 10 would be 8. 8 P's. Remember to check yourself in your calculator. Are there any more P's? Oh, 2 more. 8 plus 2, that would be 10P. And then 10 and a -1 would make 9 P's. And now again, I could come through and strike through all of the P's. I thought I had my straight line tool. We're going to go with it. Okay. So now next, we're going to look for the Q's, and it looks like the 3Q is by himself. He doesn't have a buddy, so he just comes as part of the answer. And I'd cross him off. This time I will grab the straight line so it looks neater. Okay, now why don't we do the R's first? I like to leave the constants as the caboose. The constant is the end, and all the variables kind of go first. So we've got a 1R and a 6R. 1 plus 6 makes 7 R's. And then finally, I'm looking to see my constants. And if I notice, I think there's only one. And that would be plus a -4. And you could change that same change it back to the -4. Now, I cannot go any further. I can't say, oh, well, this will be 19, 15. No, because they're not like terms. So only buddies can combine, and everybody else has to stay separate. And this would be completely cleaned up. That would be a simplified expression. Okay, so that was combining like terms, which comes into our play of working with variables on both sides today. So I just going to start right off with letting you see an example where a wireless company, so that would be your cell phone, offers two different plans. Plan A is $24.95 per month. And imagine if you had to pay 10 cents per minute. That's originally how the plans were developed, and then they came up with unlimited. But also Plan B offers $19.95. Ooh, that's the better plan, right? Until you realize that the per minute charge is more. So we're going to use the questions on page 145 to see where these two plans cost the same and in which is the better plan. So what I'd like you to do right now is you're basically going to fill in this table on page 145, have your calculator, and here's plan A. And what you're going to do is you're going to take 24.95 plus 0.10 times the 10 equals, and put the answer in, and then take 24.95 plus 0.1 times the 20, hit equals, and 24.95 plus 0.10 times 30, and you're going to fill this, and you're going to also fill this in, but this plan is different. It'll be 19.95 plus 0.20 times 10, hit equals, and write it in here, and then do the whole column. Once you've filled that, you're going to answer questions 2 and 3. For what values does plan A cost less? So where is this the better plan? Which one's cheapest? And then for what values does plan B cost less, and where do they equal? So right now you're going to stop and at least let's fill out this table and see if you can answer these questions. Okay, so let's see how you did. I'm just going to quickly go down here and you can check yours, and you're going to pretty quickly see the pattern since your inputs over here are in a pattern, your outputs, and basically every 10 minutes is adding $1, which makes sense because 10 cents times 10 would be $1. Now over here, your 20 cents is going to go up by $2 each time. You probably saw that pattern, and that's the way your table should look. Now, if yours wasn't, fix it and fix answers 2 and 3. And now let's see what happens here. For what values does plan A cost less? So notice right here, $25.95 is more. Oh, that's interesting. But right here for 60 minutes, look, 30.95 is less than 31.95. So it seems like once we get past this 50, we will start seeing that this plan is cheaper. What values does B cost less? Well, B starts costing less until this point. So on the other side of this point, plan B costs less for less than 50 minutes. So when do they equal? Well, we can see it right here, exactly 50 minutes. This is called the break-even point. It's a really important problem in business. When do two things equal the same? Which one is more profitable? Those are terms we use in business. So that's kind of what we're doing today is we're going to figure out when two things are equal. And in this case, the answer would be for 50 minutes. So here's an example of a variable on both sides. It's a very simple equation, but notice on the left there's a 4D, and on the right there's a 5D. So if you went to Woodruff bubble this one, you wouldn't know who to bubble because there's two variables. So to solve it, we have to use those properties, the idea that if we add something to the one side, we have to add it to the other. We have to use that balancing idea to solve this. And we're going to start by getting the variables together. So here's an example. And for those of you that like a visual, this is kind of what are called algebra tiles. And do you see 4x's plus 2 on the left of the equals and 2x's plus 8 on the right-hand side? And the first thing we're going to do is notice that there's x's on both sides. So we're going to get rid of these two x's. But when we do that, we have to take 2 from the other side to keep the equation in balance. So we're going to remove 2 x tiles from both sides. So you can kind of see them doing it here. We'd like to write it below, but they're doing that same kind of math. And when we do that, we're left with 2 x's on the left and 2 1's, and then we still have the 8 over here. So now this is our two-step equation that we just solved the other day. So now we're not going to touch the x's. We're going to subtract the 2, and we have to subtract 2 from the other side. And they're just doing it horizontally rather than writing it below. So now we're left with the 2x and 6. And can we take that group of 6 and divide it by 2 into 2 equal groups to kind of see what's happening? And there's going to be our check. And you should see that it's 3. Each one is 3. And here's a good check. They're checking that to make sure it works in the original equation. All right, we don't need to do the algebra tile, so let me show you this one that we just saw a second ago. And the first thing I'm going to recommend is we're going to talk about it. You have a choice right now. You can either subtract 4D or 5D. I'm going to subtract the 4D, as does the book on page 146, because it's going to keep the number in front of the D called the coefficient. It's going to keep it positive. It's the invisible 1, guys. So when they subtracted 4 D's from the left, imagine that algebra tile, they all left the mat. And now we have to subtract 4 from the 5, leaving 1 D. This leaves us with the answer already. We know that D equals 8. And notice they're going to substitute that 8, but we have to do it in both D's. So we're going to take 4 times 8, which is 32. They kind of left the line out here. They would say 8 plus 32 equals 40. And 8 plus 32 is 40. Make sure you don't just go left to right and add before you multiply. That's a common mistake. Remember PEMDAS. We always do our multiplication before we add. So I mentioned the choice a second ago. This isn't in your book, but I just want to show you how you really do have two choices. So here you could subtract 12x or you could subtract 5x. So you kind of have a choice to get those variables together. I'm going to work down this one. So here's our 0 pair, and we're left with a 7 and 5 minus 12. Think of your answer, check it in the calculator, and this would be the next line because this 0 pair drops off. And now we're at actually a one-step equation, and I just need to undo multiplying by -7 by dividing by -7. This creates a positive 1, which we're going to make the invisible 1 in front of the x, and 7 divided by -7 is -1. Make sure you didn't just think to divide by 7. That would be cutting the arm off the number, right? So the answer is -1. And if we wanted to check it, we'd put it back in for both x's in that original equation. I would multiply over here, and then add, and sure enough, it works. Now, you could have done it this way. It's the same equation. We should get the same answer. 12x minus 5x is going to give me 7x. The plus 7 is still there. And notice this time, this 0 pair leaves nothing on the right, so I have to write the 0. A lot of people make a mistake here and just kind of like move the equal sign. You cannot do that. So if you're left with a 0 and nothing else, you got to write it. This is now a two-step equation. I'm not going to touch the 7 in front of the x, but I am going to subtract the 7 that's there. 0 minus 7, 0 degrees, and it drops 7 is negative 7. This is a zero pair. Now, I'm not going to write that 0 because I have the 7x over here, and 7x plus 0 is 7x. Now, get in front. The opposite of multiplying would be divide by 7, and notice I got the same answer. So this one, this time, was a little bit longer, but it kept the positive in front for the coefficient, which means you didn't have the risk of cutting off the arm. So that, there's a plus to either way. But I have to admit, a lot of people make a mistake here, and they end up kind of goofing this idea up. Either way, we got the same answer as long as you do the correct steps for the equation that you have. So here's on page 146, one more, and then I'm going to let you practice here, with me. But notice, you could have subtracted 4n or 6n. Now, I agree with the book. I would subtract 4n because that makes this positive 2. If we had subtracted 6n, we'd end up with a negative 2n on the other side. We'd get the same answer as I just proved on the last slide, but it would have more negativity. So if you subtract so that you leave a positive coefficient, sometimes kids do better with that, okay? So I'm going to subtract 4n's from the left and 4n's from the right. 6n minus 4n is 2n. I didn't touch the minus 1. Here comes the equals. And this is a zero pair, but I'm not going to write it because 0 minus 5 is negative 5. Here comes our two-step equation we were working on the last lesson. I'm not going to touch that 2. I'm going to undo the subtracting 1, and I show it by adding 1 on both sides. I have 2n equals negative 4. And now what the book didn't show is they didn't show the dividing by 2 step, which I need you to do. So divide by 2, and you get n equals negative 2. They did do a pretty good check. I think, they leave a step out again, though. But we're going to put that negative 2 back in the original. See it? So 6 times negative 2 minus 1, will that equal 4 times negative 2 minus 5? Multiply, you should have negative 12 minus 1. Multiply, and you have negative 8 minus 5, and they both do equal negative 13. So let's just complain about the book on two fronts here. They should have showed the dividing by 2 step here, and they should show this next step in the check. They kind of jumped from here to here. Having said that, I want you to pause the video and solve the first one. We'll come back, we'll check it, and then we'll solve the second one. Okay, so you have a choice right now. Let's see what I chose. I chose subtract 5a. When I take 8a minus 5a, I'm going to get a positive 3a, and this is going to be a 0 plus 21, which is 21. Now I'm going to divide both sides by 3 because it's the opposite of multiplying by 3, and my answer is 7. I'm going to put that back in and check it to the original. So 8 times 7, does it equal 5 times 7 plus 21? I'm going to multiply on both sides. This is the step that the book often doesn't write. And then I'm going to add, and sure enough, it works. Okay, here's a little bit more complicated one. Can you pause and let's see how you do this one? Okay, now you have a choice. So you're going to subtract 3x, or are you going to subtract 8x? You're going to notice I subtracted 3x, and that's because it'll keep the coefficient of the x positive. Now, if you subtracted 8x, your steps will look different, guys, but you should get the same answer. Be careful here. A very common mistake is to leave this minus behind. This is not a positive 7. It is a negative 7. Remember, this can be plus a negative, right? So it should be have negative 7 equals positive 5x plus 23. Here comes our 2-step. I'm going to Woodruff bubble the 5x and do the opposite. Don't look at him right now. You're trying to get the 23 and the 5 away from the x. Don't try to bring the 7 over, okay? So the first thing I'm going to do is undo the adding 23 by subtracting 23. Negative 7 minus 23, think your answer, and please check it in the calculator, no matter how confident you feel. You should see negative 30 equals 5x, and the opposite of multiplying by 5 would be to divide by 5, and our answer should be negative 6. Now, if you started by subtracting 8x, you should get the same answer. Okay, I'm going to put it back into both sides and check it. Going to multiply on both sides. Oops, sorry. And then I'm going to subtract. I get negative 25 on the left and negative 25 on the right. If you need to pause the video to fix yours, please do that. But your answer should be negative 6. That is the only number that works in this original equation. So let's just finish off like we started at the beginning with the two self-help plans. Let's just talk about an application and leave it at that for today. And it's problem number 3 on page 147. Green's Gym charges a one-time fee of $50 to sign up to go to their gym. And every time you go to the gym and see the personal trainer, you're going to pay an additional $30 every session. Now, there's another new fitness center that charges a yearly fee of $250. It's a one-time fee as well. And that time, you're going to pay $10 per session. So at first, you're thinking, well, who would ever want to go to this gym? Until you realize that the per session fee is cheaper. Okay? So the first thing you're going to do, here's the words. And the first thing you're going to do is you are going to define a variable. You're going to pick a variable that's going to be the number of sessions. And the book decided to use S. And notice they're telling me what it represents. That's called defining your variable. So S is going to represent the number of sessions. And if you put S equals the number of sessions, that's the same thing. Now you're going to write an equation, and one gym is going to be on the left and one gym is going to be on the right. So remember, this is one time only. That's a constant. That $50 happens once. But the $30 happens every session. It varies. The number one mistake here is to put the S with the wrong number. 50 is a one-timer, guys, not varying. And then here's the other gym. And now we're going to solve this using our proper steps. So 1, define your variable. 2, write your equation. Step 3, we're going to solve it. They chose to subtract 10s. You could have chosen to subtract 30s, but then you're going to work with more negatives. When I subtract, I get 20s, and that makes a 0 pair, and we're down to a 2-step equation. We're not going to touch the 20. We're going to Woodruff bubble it, but we are going to undo the adding 50 by subtracting 50. And we're going to get 20s equals 200, and we're going to divide by 20, and s equals 10. And now 10 what? Is it 10 Doritos, 10 elephants? No, it's 10. Remember, you define your variable back here. It's 10 sessions. So I'm going to put that unit in my answer. Now, they do a crazy way of checking it. You can just go back into this original equation and put the 10, and you're going to see I'm fixing that kind of here. Now, for the 10 sessions, you see the bottom of the check? That $350, that's the amount of money you're going to pay at both gyms for 10 sessions. So you'll pay $350 at the first gym for 10, and you'll pay $350 at the new gym for new fitness center for 10. So I'm just going to leave you kind of with what I call the map here. This is the order of the steps. First of all, change subtractions to plus and negative. That will keep you from kind of getting confused as to who's positive and who's negative. You see some steps missed here. Those are going to get filled in later on. If there are variables on both sides, you're going to collect the variables on one side of the equation like we did today. And then you're going to be left with either a 1 or 2-step equation. And you're going to undo the adding and subtracting first, and the multiplication and division second. And then you always check your solution in the original equation using your order of operations. So today we put a variable term on both sides. And what you might notice is we keep practicing these same steps. We keep ending up with usually a 2-step. So we will continue to practice those equations as we move forward. Okay, it's your turn. When you come into class, we'll do some together, and then you can give it a practice. Have a great day, everyone.